Right then. Talking about this question finally is to find out the volume, okay, that of the seawater needed, okay, to produce 1 ton of I2, right? So we know
Yeah.
first equation that comes to our mind, since we see the mass here and the question is volume, we know the equation that commonly connects volume with other factors is concentration equation. Concentration equal amount over volume, right? Which means volume equal amount over concentration. Okay, now the question is, if I can find out the amount that of 1 ton of iodine, which is I2, and the concentration, I can find out the answer. Finding the amount here is not a big deal. The reason is N equal M over MR. M is given as 1 ton. We know, Sheha, what unit do we substitute that on finding the amount? If it is 1 ton, do we just substitute 1?
No, it would be like 1 million grams.
1 million grams, but yeah, that's right. And we normally substitute in grams. So 1 times 10 to the power 6 gram, right? Over
Yeah.
mole mass that of I2. So you can use the periodic table, and we had already found I2's mole mass that was around 253 point something. Would you mind reminding me the decimal number?
126.9.
No, for I2,
Oh,
I2.
for both of them, yeah.
Yeah,
Um, yeah, 253.8.
8, right? Okay. So
Yeah.
I'll just substitute that 8. Okay, 253.8 here. That gives us an answer to the amount, and you had used the calculator initially to find that. That was 3,940 moles, right? Ignoring the
Yep.
decimals. Okay, this amount is found. Now our question is to find out the missing concentration, right? Okay, now we have to further check on the data that are provided. That's when we will understand what to do further. We are given the concentration, but that of Ki in gram per dm cube, right? But we
Yep.
need the concentration that of I2 in mole per dm cube. So there are two things to do. Whatever given here is not I2, that is Ki. And the amount given here, I mean, concentration given here is not in mole per dm cube, but in gram per dm cube,
Um,
right?
yeah.
Okay, anyways, first thing that we've understood is we have to interrelate I2 with Ki to do this reaction. I mean, do this question. To do this question further on finding the concentration. So that's when you can think of the reaction, because they already talked about chlorine reacting with it. So this equation, as I already said, I'm skipping the physical states because you know what happens, is a reaction that we are doing from our GCSE levels, right? And what comes here? I2. So
Yeah.
balancing, you will put a 2 here and a 2 here. So first thing, if you understand, since you have found the amount here, that's from this, right? Do you understand
Yeah.
you can times it by 2 to find the amount here?
Yeah.
We can, right? So let's straight away do that. That was giving us an amount that of 7880 mole, right?
Yeah.
So if you realize, this will be the amount of Ki needed to produce this amount of I2, which is 1 ton in other words, right?
Yeah.
Okay. Now that is the needed amount to produce 1 ton of. But really on 0.15 gram per dm cube, how much will be the amount present? So let's find out. So we're going to find the amount, okay, in 0.150 gram in 1 decimeter cube. So keep that 1 decimeter cube as it is. That will straight away give you the concentration. Concentration is 0.150 gram per dm cube. I can write it that way, right?
Okay. Yeah.
Okay. And 0.150 gram, but that is from Ki. Hence, do you realize that mass can be rewritten as amount by doing mass over molar mass? M over mr over 1 dm cube will give us the amount. That is straight away our
Oh. Okay.
concentration in the unit mole per dm cube. That is our concentration in the unit mole per dm cube, right? Can you find
Yeah.
out that? So this is still 1 dm cube. I mean, we do not need that since I took it here. 0.150 over Ki's molar mass. We found it, so let's not waste time. That was 166.
Yeah. Hello?
Yes. Do you have an answer for that concentration now?
Yeah, is it 9.036 times 10 to minus 4?
This for the concentration. 9.036 times 10 to the power minus 4. So if you realize that's the concentration of Ki in mole per dm cube. Yeah?
Yeah.
Okay. So in 1 dm cube water, we have this much amount. So let's find the volume of the water in which we will have this amount of Ki. Because do you realize we finalized saying this is the amount needed so that we will get 1 ton of I2. We remember that, right?
Yeah.
At this point, if you remember very well, at this point, we finalize saying this will be the amount that of Ki needed. If that amount is available, we will get this amount of I2, which is 1 ton. So simply now, let's find out the volume needed to produce that amount. So again, coming to this equation, we know we are not going to substitute this for I2 because I2's concentration, we have no way of finding. But one thing that we found out, we can find this amount needed again using C equal N over V, so V equal N over C, which will exactly be the volume needed to produce that 1 ton, right?
Yeah.
Okay, for an example, let's say you found out you need 4 eggs to make a crate, okay, something. And you wanted to find out the volume of water needed to prepare this, but then you couldn't. But if you find out the volume of water needed to mix here, don't you think that is the volume of water needed over here as well? It's the same,
Yeah.
right? The process is the same. So that is why we are not interested anymore in finding the concentration of I2, because we know finding the, I mean, we have the amount found here readily, concentration found here readily. That volume is exactly what we need here. This is the reactant, that is the product. That's the only difference. So going back to the equation, volume equal amount over concentration. Amount needed is 7,880 moles. Concentration is found on 1 dm cube. How many moles is already found, which is this. So you get the volume. And volume will be, can you double check the answer using your calculator? This amount of dm cubes. Tell me if it is the answer. Just that final part, if you end up having the same answer.
I got 8.72 times by 10 to power of 6.
Yeah, that's right. That's what I wrote, right?
Yeah.
Okay. So can you tell me what we did now? You don't have to follow my exact steps. You just can give me the general idea of what we did or how to do this question. If you want to prepare, take a minute or two. If you want to prepare, what you have to do.
I think that first, like what you did was you wrote out the um equation, and then you needed to manufacture 1 ton of I2. So to find the moles of that, you just did mass over molar mass,
Mm-hmm.
and then you found that the moles was 3,940.
Mm-hmm.
And then since there is 2 Ki, then you times that by 2 to find the moles for Ki.
Mm-hmm.
And then to find the end volume, it's volume equals moles over concentration. So we have the moles for um Ki, but we need the concentration.
Mm-hmm.
So the question says that it's 150 grams per dm cubed.
Mm-hmm.
So um you just find the moles, since concentration is moles over volume, and you can do that using mass over molar mass
Mm-hmm.
of Ki. And so the concentration is then like 9.036 times 10 to the minus 4.
Mm-hmm.
So then you can use it in the final equation for volume.
Mm-hmm.
So if you just find the volume of um that's needed for Ki, it'll be the same for iodine. So it's just the moles over concentration, and that's the final volume.
Yes. So we see by the time we started, we wanted to find the volume needed to produce that product. So the C equal N over V was written for I2. But then later we realized we do not have enough data there. So we thought of we were thinking of finding the volume of seawater needed to extract that amount of Ki. Either way, the answer will be the same, right? Because the I2 is a product that comes from Ki, right? Okay.
Yeah,
Hope it's clear.
yeah.
Okay.